Yo, what's good? Welcome back to another episode of How to Algebra. In this episode, we're going to be diving into the exciting world of sequences, specifically arithmetic sequences. These are the stepping stones of math, where each term is a constant difference away from the one before it. So we'll explore how to find the common difference and then calculate any term in the sequence. So let's get ready to level up your math game. Let's get it. All right, so let's start the conversation with what is a sequence? So, simply put, a sequence is just a list of numbers. Right, I'll give you a couple examples. So we could take the natural numbers, for example. All right, so here's a couple sequences, right? There's no, it's not a hard concept. All right, it's just a list of numbers. Okay, so specifically, we're going to look at arithmetic sequences, which have a very particular pattern, which we'll explain in a second. So before we get to that, let's just talk about some notation, right? Because I think once you understand what you're looking at as far as the notation is concerned, sequences is actually really easy. So I gave you a list, 3 examples. All right, so more specifically, and I guess in general, actually, a sequence is going to look like this. Okay, so remember, a sequence is just a list of numbers. So here's a list. So this is how you're going to see it. And we can use A to represent the real numbers, right? A can be the numbers in the sequence. The subscript, that's the also known as the index. So also known as the index. So the index or the subscript, the lower number, it has zero, right? It has zero mathematical properties, right? It is not a mathematical number. All the subscript or the index does is tell you what spot in line that the term is. So A sub 1, right? This is the first term or number in a sequence. All right, and we know it's the first term because of the subscript. Well, not only that, but it's the most left number, right? It's first in line, basically. The subscript has a 1. So that's how I know that it is the first term. So for instance, A sub 5, this is the 5th term. Again, because the index is 5. So now, a sequence could have however many numbers the sequence has. There's no set number. It basically just has to be more than 2. So we can have up to n numbers, right? N is the variable we use for the index, right? So if n is equal to 10, then we're referencing A sub 10, which would be the 10th term. The 10th term, or the 10th number in a sequence of numbers. So that's basically what it comes down to, right? A sub 1, A sub 2, all the way to A sub n, however many numbers there are in a sequence. Okay, so with that being said, if a sub n is some number in a sequence. So a sub n is some number, then the very next term or the very next number in the sequence would be n plus 1. And then the next one would be n plus 2, right? N plus 3, n plus 4, so on and so forth. So it's a way of ordering or assigning a number value or an order to a list of numbers. All right. With that being said, the number or the term, so let's just say a sub n, right, is the first term. So n would be 1. So we would have a sub 1. Then the next, so since n is 1, right? Since n is 1, the next term would be a sub 1 plus 1, which would be a sub 2. And then a sub 2 plus 1 would be a sub 3. And this would be so on and so forth until you get to whatever number. Okay. Now, that's if n is equal to 1. But say n could be the 10th term or the 9th term or the 50th term, right? N is just some number that's in the middle of a sequence. Well, then if n plus 1 is the number following it, like the next number, the previous number, the number before it, would be, feel free to answer in your head, n minus 1. So these three in particular are going to be what you're going to see the most of. Like, you're going to be utilizing these three terms specifically. So what I'm saying is, when you see the notation, right, understand what you're looking at. So a sub n is just a term. In fact, it's the nth term, where n could be whatever number you want or whatever number is specified. All right, n plus 1, it's the next term after n, or after the nth term. And n minus 1, well, this is just the term before the nth term. All right, so I know it's a lot to digest right at first, but I truly think that once you understand how to read the notation, right, how to process what's happening, it gets easy for sure. So to recap, we have a list of numbers, right? A sub 1, a sub 2, a sub 3, dot, 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 all the way up to the last number in the sequence, a sub n, where the subscript or the n value tells you what spot in line in the order of the numbers, like what order or what place a particular term is. All right. In general, the way we refer to the terms, we use a sub n, right? N being the nth term. And then we can say a sub n plus 1, that is the next term after n, and a sub n minus 1. That's the term prior to n. All right, so we're going to use this in a couple of different ways. So far we've just talked about sequences. So now we're going to look at what an actual arithmetic sequence is. All right, so an arithmetic sequence is a very specific sequence. It's a sequence where all right, so an arithmetic sequence, in other words, it's a sequence where any term that you pick is exactly the same constant value from the previous term. So a constant value meaning a whole number, right? It's a whole number away from the previous term. And then every term is that exact distance from the previous term. So watch, I'll give you an example. So the most basic example is the counting numbers, right? The natural numbers. It's actually kind of boring, but I think it gets the point across. All right, so say you have 1, 2, 3, 4, 5, 6, dot, 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 all the way up to some number n, right? N is a whole number. All right, so the idea is that every term in the list is exactly, so I'm pretty sure you can already see it because it's kind of obvious, is exactly one number away from the previous number, right? 2 is 1 plus 1. 3 is 2 plus 1. So I'm adding 1 to the previous number every time. So I'm starting at 1, and we're just adding 1. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5, all the way up to until we hit or until we reach whatever number is the last number in the sequence, right? So this idea, right, this difference of plus 1 every time, we call this has a name. It's called the common difference. Common difference. All right, so it's the same number in between each term. Now, if one of these numbers were different, then this wouldn't be an arithmetic sequence. It would just be a sequence. So an arithmetic sequence specifically, it has the common difference between every term. And that common difference is one number, one value only. And it could be whatever the value is, right? So the variable that we use for the common difference is a lowercase d. So it's denoted as d. All right. Moving right along. So, for instance, I'll give you another example. Again, here's a sequence. And the question is it an arithmetic sequence? Well, to determine if it's an arithmetic sequence, we have to see if the common difference between each term is the same. So between 6 and 4, the way we got to 6 from 4 is we added 2. And then the next term would be 8, so we added 2 again. Then 10, 12, 14, and so on and so forth. So yes, this would be an arithmetic sequence. So the arithmetic sequence, and it has a common difference of 2. So we want to identify, is it an arithmetic sequence? And if it is, what is the common difference? All right, so now let's talk a couple of formulas. So if the sequence is given to you, such as I've given it to you just now, you can identify the common difference fairly quickly just from looking at it. Now, some questions, 2 questions in particular that you're going to see usually are, can you continue the sequence? And because like here, I've only given you 1, 2, 3, 4, 5, 6. I've given you the first 6 terms. All right. Could you come up with the 10th term or the 50th term or the 100th term? What would the 100th term be if the pattern kept going? That's one of the questions. And then not only that, but there's a formula that I'm about to show you that you can find any term in the sequence. So the formulas, and these would be best committed to memory. So first off, let's start. So we're going to use the common difference. So a sub n, so any term any term that you want will always be the previous term plus the common difference. So any term you want can be identified by taking the previous term and then adding the common difference. Kind of seems kind of trivial, right? All right, so we call this a recursive formula, right? Because it takes a number and it adds the common difference to it, and you get a new number. And then to get to the next number, you just add the common difference again. All right, so for example, if I wanted to find what the second term in a sequence is, so that would mean n is equal to 2, right? Because it's the second term. So I just fill in 2 wherever there's n. So a sub 2, right? That's a sub 2 is always the second term. This would be a sub 2 minus 1 plus whatever the common difference is. So that's going to be basically 2 minus 1 is 1 plus the common difference. So this should make sense, right? That the second term in a sequence, it's going to be the first term plus whatever the common difference is. And you can keep this going, right? It's recursive. You can keep it going. Just so you can see it, right? The third term, a sub 3, would be a sub 3 minus 1 plus the common difference. So this would be a sub 2 plus the common difference, right? And you would just keep this going. Okay. So that's how do you get to the next term. But for this to work, you must know, right, what the starting term is. So the first term must be known. So the first term must be known. So in general, the general formula, now as long as it's an arithmetic sequence, the formula I'm about to give you is going to always be valid. All right, so any term in any arithmetic sequence can be found by, can be found by taking the very first term in a sequence, and then you add to it n minus 1 times the common difference. So for instance, if we use our example that we have up above, so 4, 6, 8, 10, 12, 14, if I want, so find, let's just say the 30th term in the above example. So find the 30th term. So this means 4, 6, 8, 10, 12, 14. Now I could brute force and then just keep the pattern going and then count, but that would take up some time, right? So what I'm going to do is we're going to apply the formula. So I'm looking for n equals 30. In other words, I'm looking for a sub 30, right? The 30th term. So this is going to be, so a sub 1, the first term, we know is 4, plus I'm looking for the 30th term. So n is 30, so 30 minus 1 times the common difference. Well, in the above example, the common difference is 2. So doing some math, we're going to get 29 times 2. All right, so 29 times 2. So 30 times 2 is 60. Minus 2 would be, so 58. So 4 plus 58 is equal to 62. So if I kept the pattern going, 4, 6, 8, 10, 12, 14, ... the 30th number would without a doubt be 62. Oh, it's kind of interesting. So the big takeaway from this whole lesson is that the general formula, a sub n is equal to the first term plus n minus 1 times the common difference. So regardless of what sequence is in front of you that you're given, first you see if you can recognize a pattern. What is the difference from one number to the next? And if you notice that you're adding the exact same number every time, well, then that's an arithmetic sequence. And we know that in an arithmetic sequence, the general formula, which is in the red box, will work every time to find any nth term. So whatever term, the first, the last, the middle, the 30th, the 100th, whatever, right? It works. All right, so let's see some. Well, actually, that's pretty much it for the lesson. I will post a homework video where we dive deeper into some more examples. All right.